All right, the plan for today's prep is to go through these questions as many as we can, and then give some help to assignment. Okay, I can give individual help via breakout rooms if you want. Okay. All right, let's do question 1. Construction of a function with some specific criteria, especially the function f is defined for all real, f dash exists and is negative for all x not equal to 0, and the point x equals 0 is a local maximum of f. Okay, can you think of such a function? Give an example. I'll give you a little bit time to think about it. Anyone? Can you think of such a function? It's okay if you get wrong, just try. You can use Mathematica to plot it. Okay, I'm not seeing any answers. Can you just try a little bit more? How about plot just any function? Okay, and then let's say plot x squared. This is how you would plot. This is an example. Okay, not the solution to this question. Let's say -5 to 5. Okay, that's how you would plot a function. Okay, now can you change this to the criteria? Give me any function that would satisfy the criteria. Okay, just give me something. Okay, Kai says any concave even function would do. Can you give an example of such a function? Like that's a description. Thanks, Kai. Okay, there's an answer which says e to the power x to the power 2. Okay, so did you mean, okay, let me try that. E to the power x squared. Does that satisfy the condition? All of them? Let's check it. This is defined for all x, but f dash exists and negative for all x not equal to 0. Negative on the left, but that's increasing. Okay, that should be positive. So second criteria is not satisfied. Any other guesses? Okay, I can give a hint. Use a piecewise function. Okay, it's really like the function is decreasing on the left. Okay, and then maximum is at 0, and again it's decreasing. You could use Mathematica to explore plot piecewise functions. There is a using piecewise function given in Mathematica, for example. Okay, this is a piecewise function where when x is less than 0, it's x squared. When x is bigger than 0, it's minus x squared. Okay. Okay. So this is just a demonstration to show that you can use piecewise function in Mathematica to plot. Okay? But that's still not a good example to satisfy the criteria. Why? It should be less than or equal to. Okay. Any hint? Can you try to change the left-hand side function so that it's always decreasing? Your quiz is, I think, next week. So like questions like this would be helpful, I'm assuming. Given these conditions, I imagine it should be piecewise, but if you could think of anything else, that would be great. Okay, right. Change this. Some function which is decreasing. Okay, how about this? 1 over x. Does that book sit satisfied all the conditions? Should be less than or equal to. All right, any question? Okay, no questions. Let's move on to the second question, second part. You're given a graph of a function in the interval -2 to 6. List all critical points in the interval, in the open interval -2 to 6. Okay. Give me the critical points, and then I'll try to write it down. It shouldn't be hard. Okay. Can you give me at least some of them? There are many. X equals, is it -2, -1? We are considering the open interval, -2 to 6. Okay, there is a critical point at -1 +1. Are you sure it's +1? When x equals -1, that is a whole, okay? The point is here, so it should be -1, -1. Okay? And 0, -1, yeah? So there is a critical point at x equals -1, -1. Which is the derivative defined at that point? Does the derivative exist or undefined? Undefined, yeah. Why? Because at this point you can't draw a tangent line. Okay, so it's undefined and it's a point of discontinuity. Okay. Anything else? Kai, you have said 0, -1. 0, -1 is a critical point. Is the derivative defined or undefined? Undefined. Okay, it's a corner. Corner. Okay, derivative is undefined. Anything else? 1, 0. Yeah. 1, 0 is also a corner. Anything else? It's a vertex. Any other critical point? I'm not seeing anyone else's contribution. Can the others please contribute too? It doesn't matter whether you're right or wrong. 2 minus 1. Okay. 2 minus 1. Is the derivative defined or undefined? Undefined, yeah. Anything else? 50? Are you sure it's 50? 51, yeah. Is the derivative defined or undefined? Undefined, okay. Why? What sort of the slope is vertical. I mean, the tangent is vertical. So it's undefined. It's a point of inflection. Okay. Anything else? There are others, many more. Can you figure it out? Three, one. Is that the only one? 3 minus 1, that's it. Yeah, very good. So the points in between, sorry, 2 to 3. Okay. Now, is the derivative defined in that interval? That part is parallel to x-axis. Is the derivative defined? Yep, defined, it's equal to 0. Yep. Yep. Okay. That's really good. I can share some document which really helps. Okay. That document shows these discontinuities, corners, and then whether the limit exists or not. Okay. Is there any question regarding that part? Kai, to be honest, I'm not sure. Okay. If you give me a little bit time, next time I will try to figure it out. Question 3. Show why PT is equal to, this is called the growth curve, is only solution to the growth equation P dash equals KP, okay, with P0 equals the constant. How would you approach this? Any ideas? Okay, I can give a hint. How about you start with what? PTV equals to a function. AT e to the power KT. How about you start with that? Okay. Take the first derivative and use this equation. What do you get? Compute P dash and substitute into this equation. Okay, what do you get? What's the derivative of pt? The idea is to show that at is a constant in that case. Okay. What's the derivative of pt? P dash, that's P dash. That's what we are trying to find, a function of t. Yes, at is a function of t. Our aim is to show that at can only be constant. Remember, e to the power kt is positive. Okay, what's the calculus rule that you need to use for that derivative? Yep, yep. Kai, you are right. Take the derivative and equal it to kpt. Yeah. Okay, what sort of rule do you use to find that derivative? Chain? There is chain rule also. Okay, first, we are going to use product rule. Okay, so it's 80 times e to the power kt plus 80 times then you derive e per kt. That would be e to the power kt times k. All right, that's p dash t. Then we need p dash t equals kpt. So that's, yeah. Yeah, you're right. I'm just trying to make this simple. There is an ODE technique. Yeah. But you haven't covered that, which is e to the power 30. Okay. What do you notice? I'm going to divide through by e to the power kt because that's positive. Okay. What does this mean? Yep, that's very good. This means a dash t must be equal to 0. And thus at is a constant. Okay. Say C. Therefore, we have in this case PT equals any questions? No? Okay, let's go through the last question. Maclaurin series. What is a Maclaurin series? What is it related to Taylor series? I believe you have covered this. Yeah, Maclaurin series is a Taylor series at a equals 0. In Mathematica, you can use series function to compute the series expansion up to a specific order. Okay. In this case, I have computed Taylor series of fx. Fx is not given yet, up to order 4 at the point A. Okay. So if you want to compute Maclaurin series, which would be A is 0 in this case. Okay. So in particular, if you have e to the power x, you would get oops. I think it should be. Yep. Okay, so this series can be given in compact form is the sum of xn to the power n factorial. Okay, you can try that. Let's see. So these are the first 4 terms. How do you relate this to inner product? I'm not sure. That's up to 5. And then you can compute the series expansion. But in summation form, this can be written as x to the power n divided by n factorial. That is sum of. Let's try that. So this means sum of x to the power n divided by n factorial, where n goes from 0 to infinity. That's e power x. All right. Thanks, Kai, for the information. All right, I'm going to use this sum notation to compute the approximation. In order to get the approximation, what you could do is take the limit of the sum up to n terms as n goes to as up to k terms as k goes to infinity. Okay, for example, let's write a function to compute that. Okay, let's compute this to 4th order. Okay, we get that. And up to 5th order. That's it. Okay. Now can you write a mathematical program to plot this with e to the power x curve? You can take x from maybe 0 to 5 or 10. Or maybe F4. X goes from X can go from 0 to 10. We don't know. Let's define the plot legend. Okay, so the blue curve is the e for x, and that's f of 4. Okay, is that right? How about if we change this to f of 6? Does it get better? Yeah. So you can see that it's getting closer and closer to the approximate value. I mean the approximated curve. Okay. Is there any question? Now, instead of every time changing this number, you can use the manipulate function where you would change the k. Instead of changing every time changing this number. Seven. All right. This is like playing a video that goes from k goes from 0 to 10. Is there any question? All right, I'll be here for another 5 minutes to give you assignment help. Let me stop the recording.